In this video, we are going to look at patterns and how to find formulas for patterns. You might have seen this pattern before in primary school, built from a set of matches. So in this pattern, pattern 1 would have 3 matches. Pattern 2 would have 1, 2, 3, 4, 5 matches. Pattern 3 would have 1, 2, 3, 4, 5, 6, 7 matches. Pattern 4 would have 1, 2, 3, 4, 5, 6, 7, 8, 9 matches. So this was fairly easy to count them every time, but we definitely don't want to keep drawing this up until pattern 10, for example. So let's see if we can find out what is going on in this pattern and if there is any structure in the picture itself that could help us. It seems like I'm adding 2 every time if I merely look at my numbers. So 2 plus 2 plus 2. This is one of the first things you can do if you see a pattern like this, because it gives you some indication of what is happening. So what I mean by that is, in each case we add on 2. Have a look. There's 2, and then I add another 2, 2, 2. So there I've added 3 2s. Here I've added 4 pairs of matches. But every time there's this match in the beginning that doesn't change. So if that was a bit confusing, let's write it out. So in my first match pattern, I have 1 and 2 matches. That makes 3 matches in total. In my second pattern, I start off with that 1 diagonal match, and then I add 2 and another 2. So I add 2 pairs of matches, so now I have 5 in total. In my third one, I start with that 1 diagonal match, but for this one, 3 pairs of matches were added. In my fourth one, 4 pairs of matches were added. It seems like I can definitely extend this pattern. So if I have to ask you, what would pattern 10 look like? And remember, the notation we use is TN, because that refers to term 10. And later we're going to do TN for the pattern. So that basically means pattern number N for natural numbers. And here we have pattern 10. So what will happen in pattern 10? Well, that will be 1 and 10 2s. Oh, sure. So that's quite a long process to write that out. Maybe I can write this a little bit shorter. What about 1 plus 2 times 10? So that means there are 10 2s and that original 1 diagonal match. Okay, so that looks like we could make a formula from that. So what would that formula look like? That would be 1 plus 2 times n. And remember, we don't have to write the times sign. We can just say 2n. If this was all very fast, let's look at another example where we're going to do this in a similar way. So here we also have a pattern made with matches. So let's see what's going on here. In my first pattern, I have 1, 2, 3, 4, 5, 6 matches. In pattern 2, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 matches. Looks like I'm adding 5. Let's see if we add 5 for the next one. Here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yes, indeed, it seems like I'm adding 5 every time. So let's go and write that in, because that's always the place that we start to see how much I add from the previous one to get to the next one. So in the structure of these houses, what does that look like? What is the thing that stays the same and what is being added every time? So to me, it looks like we are adding this every time. So that's 1, 2, 3, 4, 5 sides that I add every time. But we start off with this one side of the pattern over here. So let's see if it works the same for the next one. So 1, 2, 3, 4, 5, and another 1, 2, 3, 4, 5. Okay, and my third one will be 1 and 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So that means in pattern 4, if I had to draw that out, it would be 1 plus 5 plus 5 plus 5 plus 5. And that should give us, if I add on 5, what am I getting to? Ooh, sorry, I see I made a mistake here. This was 16, so let's just fix that. That was 16, so that should give us to 21. That's right, so this one is 21. This way of writing it out also helps me to get to my formula. But first, let's try to find pattern 10 or term 10. So term 10 will therefore be 1 plus 10 fives, and to do that in a short way, I say 5 times 10. Let's see what that is equal to. So that's going to be 51. And then my Tn, or my term n, or my formula, will also be 1 plus 5 times n, or we can say 5n. And remember, there's no answer for this because this is just our formula. Okay, let's look at another pattern. So here we have a pond. So the blue that you see there is the water, and there are the blocks around it. So they tell us this is size 1, size 2, and size 3. Let's count how many blocks I have. 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 pavers in my first one. The pavers are the things that go around, cement blocks, pavers, whatever you want to call it. Let's look at the next one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ooh, is it really just 2 more? Okay, it looks so big. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Ooh, so this one increases with 2 every time. Let's see if we can use the picture to help us to figure out what's going on. So we have to look at what stays the same every time and what changes. So you can see that the water in the middle just becomes longer a little bit every time. So it seems that what I'm adding is in the middle, but the sides stay the same. So these sides in each case stay the same of my pattern. And then I just make the middle bigger every time. So in my first one, I have 2 on the sides. In size 2, I have 4 on the side. Size 3, I have 6 on the side. So if I have to find term 10, if I had to make a rough drawing of what this would look like, I would have the 3 on the sides. And in the middle, I will have 1, 2, I will have 2, 4, 6, 8, 10. How many times do we do this? We have to do this 10 times. Sure, this is very long. Okay, let's see if I can write that shorter. So I have the 6 ones on the side and 10 pairs of pavers on either side. So a pairs is 2, so that means I'm going to say 2 times 10. Maybe you've noticed this by now, but what I add every time in my pattern is also what I multiply with. Do you remember that in the previous pattern, I added 5 every time and then I multiplied it by 5? And in my first pattern, I also added 2 every time and I multiplied by 2. So whatever you add between your numbers is the number that you multiply by. Let's see what this answer is. This is going to be 26. So now what is our Tn, or our formula? This will be 6 plus 2 times n. Okay, I hope that made sense, because now we're going to look at an example without a picture. This example is quite tricky because now I also have negative numbers. So let's see if I can figure out what's going on. Like before, I'm going to start by seeing what we add in between every time. So here I've added 4, here I've added 4, here I've added 4. So luckily I already know that in my formula, that means it's going to be 4 times something. So let's have a look at this first one over here. Let's circle that in yellow. So they're saying if my first number is -1, so it's almost like I have term -1 over here, which means I have -1 over there. 4 times -1 gives me -4, but they tell me that the answer is actually -5. So how do I get from -4 to -5? Well, that means I need to minus 1. That looks strange. Let's see how it works for the next one. So the next one, they say we have term 0, and that answer should be -1. So for term 0, I will have 4 times 0 in my brackets. So that's 0. And how do I get an answer of -1? Well, 0 minus 1 is -1. Let's see what works for the next one. So here I have term 1. I know I need to multiply by 4 every time, and now it's 4 times 1. And my answer in this case is, let's just use a different color here. My answer here is 3. So how do I get from 4 to 3? I minus 1. So looking at this, it seems like I can write a pattern. So that means every time I multiply by 4 and I minus 1. So that's going to be 4 times n, or 4n, minus 1. Now, having a formula like this is really going to help us to find the value of a and b. So to find the value of a, it seems like I need to find the value of pattern 8. So that means over here, I'm going to say 4 times 8, which is 32. And if I minus 1, that gives me an answer of 31. So therefore, A equals 31. But what about B? How can I work backwards from 59 in order to get B? This one is a bit tricky. So that means I'm looking for term B. I know that it's 4 times something, so we can say 4 times B, or 4B, minus 1, and this is equal to 59. If I have to work backwards, it means I'm going to say 59 plus 1 divided by 4. So 59 plus 1 is 60. And then if I say 60 divided by 4, that should give me my answer of what B is. And hopefully you know that 60 divided by 4 is 15. So here you can really see that once I have my formula, I can either put the pattern number in, or I can put that value in and work back and see which pattern it is. So formulas are super useful, especially in real-world applications, in finance and engineering and all those fields. So there definitely is a good use of algebra, and patterns is a nice way of introducing that.